Hello YouTube, welcome to my video. This time we are going with probability and chances. It is interesting to note that probability theory has its roots from gambling. People like Gerolamo Cardano, an Italian, I hope I pronounce his name right, and several mathematicians like Fermat and Pascal's has laid the groundwork in their attempt to analyze game of chance. While the content is strongly related to gambling, I don't condone gambling, so please don't gamble. And I will tell you the reason why. It is extremely easy to misunderstood your probability of winning in a game of chance. So please don't gamble. The first problem probably originates from gambling. There are four cards of two sets of color. Let's say the aces of poker set, like the ones we have here. We place them face down and shuffle them. To win the game, player has to choose two cards of the same color. What is the chances for the player to win? At first glance, it looks like 50-50. After all, you just take two cards out of four, but the real rate is actually lower than that. Let's think of it this way. You pick one card and left with three. Of this, only one of the same color. So your actual chance is actually 1/3. The probability 3 looks like this. And they are equally likely, so therefore you only have 1/3 of a chance of pulling the same color. The second problem is a variant of two children problem. Here is the question. A shopkeeper says that she has two new baby beagles to show you, but she doesn't know if they are both male, both female, or one of each. You tell her that you want only one male, and she telephones the fellow that is giving them a bath. Is at least one male? She asks him. She receives a reply. Yes. She informs you with a smile. What is the probability that the other one is male? Well, in a simple word, there are two dogs. One of them is male. What is the probability that the other is also male? 50-50? Let's think again. To find the right answer, let us call the first dog X and the other Y. We start with four possible equally likely combinations. If the question was simply the probability that one of the dog is male, then 50-50 is the correct answer. In our scenario, we know that one of our dog is male, which could be either X or Y, eliminating option 4. But this does not affect the other options, the three remaining possibilities which are still equally likely. The statement that one of the dog is male is true regardless any scenario we are in. In these three equally likely possibilities, there's only one of them both are male, and thus the answer is 1/3. The last question is a very interesting one. The question was originally posted with solution in a journal published in 1975. It became famous in 1990 as it appeared in Parrot magazine. It caused a furore as readers, many who are PhD holders in mathematics, disagreed with the columnist's proposed answer. The question goes this way. Suppose that you are on a game show and you are given the choice of 3 doors. Behind one door is a car, behind the others, goats. After you pick a door, the host, who knows what's behind all doors, open one of the unchosen doors, which always reveals a goat. He then asks you if you want to switch to the other unopened door. Is it to your advantage to make the switch? At face value, this appears to be a very silly question. After all, there are only 2 choices left. It's either open the door with a car behind or a goat. It's 50-50, isn't it? However, the columnist suggests that it's better to switch. So, who are right between the columnist and the thousands of readers who thinks that 50-50, it's 50-50? If you agree to make the switch, you're probably smarter than these PhD holders, because it is the correct answer. Why is that so? Let us step back and think for a while. The chances of picking the right door out of 3 at the beginning of the game is 1/3, while picking a goat is 2/3. Since the host always open another door that has a goat behind, after you choose a door, it still does not affect your chances of picking the right one out of the 3, and therefore it is better to switch. The probability table looks this way. Let's say we are choosing door 1. So we'll be end up with a goat, and a car. From here, it is clear that it's better to switch. From here, it's clear that from 2 out of 3 scenario, it's better to switch. There's detailed answer on Wikipedia, which if you still don't understand this question, you should read it. Thank you for watching my video. If you like the content, please subscribe. Bye bye.